Assalamualaikum and hello everyone. Today I want to share with you about regulation of glycolysis. So the regulation of glycolysis process started with glucose. Glucose was converted into glucosic phosphate. Then glucosic phosphate was converted to fructosic phosphate. Then fructosic phosphate was converted to fructose 1,6 bisphosphate, and then fructose 1,6 bisphosphate was converted into glyceraldehyde 3-phosphate, and then 1,3 bisphosphoglycerate, then 3-phosphoglycerate, and 2-phosphoglycerate, and then PEP, and finally is pyruvate. So this step is also the same, but dihydroxyacetone phosphate cannot convert into 1,3 bisphosphate, so we need to convert to glyceraldehyde 3-phosphate first, same as this one. So glyceraldehyde 3-phosphate convert into 1,3 bisphosphoglycerate, and then 3-phosphoglycerate, and then 2-phosphoglycerate, and then PEP, and finally pyruvate, same as this step. So here, this process here was make 4 ATP, that this one, this one, this one, and this one. So we start at this process first. When glucose was converted into glucosic phosphate, the enzyme that involved in this process is enzyme hexokinase 2. At this process also the ATP was added into this process. Then another enzyme that can be used into this process was enzyme glucokinase, but this enzyme was in the liver. Glucose can be a stimulus to stimulate this glucokinase enzyme to get out from the liver and can be used into this process. But when glucokinase was used into this process, it needs to get back into the liver. So fructosic phosphate can be used to inhibit glucokinase and put back this enzyme to the liver. Insulin and glucagon also useful in this process because insulin can be used to stimulate this both enzyme hexokinase type 2 and glucokinase and decrease this enzyme to add into this process. Then glucagon is used to inhibit both of these enzymes to back to the normal. We move to the next step, that is when fructosic phosphate was converted into fructose 1,6 bisphosphate. Here, the ATP also was added into this process, and enzyme that used in this process is phosphofructokinase type 1. We already know that ATP was added into this process and converted into ADP. So, if this process was produced enough ATP to our body, then the ATP can inhibit this enzyme phosphofructokinase 1 to reduce the process. Citrate also useful in this process because it can lead to producing the ATP. And then, when ATP was converted into ADP, the ADP can stimulate the phosphofructokinase 1 type 1 to increase the process. Another things that we need to know is there is small amount of fructosic phosphate that react to enzyme phosphofructokinase type 2 to make the fructose 2,6 bisphosphate. And then this fructose 2,6 bisphosphate can stimulate the phosphofructokinase type 1 enzyme to add into this process. Then we look at this process when PEP was converted into the pyruvate. At this process, the ATP was produced and the enzyme that used in this process is pyruvate kinase. So here, the ATP can stimulate the pyruvate kinase to add into this process. Also, LCFA-CoA and glucagon and acetyl-CoA also can be used to stimulate the pyruvate kinase. Additional things that we need to know is fructose 1,6-bisphosphate is a feed-forward reaction. It's telling the enzyme pyruvate kinase to get ready to increase the activity because to convert it into the pyruvate. That's all from me. Thank you.